But the easiest path to get there is you go into an extension marketplace, whether it's VS Code or OpenVSX or compatible. You install the plugin, and what that does is it starts a process for a server built in Go, and the notebook UI talks to this server over gRPC, and it builds out an environment, and it executes commands, and it handles all the metadata and everything else. So you can see here we have just plain old Markdown that literally any README in your repository with code in it or commands in it or anything else. You install the extension and you open it up, and now you have notebooks, which is pretty fun. So now each command, when you hover over it, actually has a play button, and you'll see down below the commands here, there's drop directly into a terminal, add a name to it, add tags to it, so you can build out sort of these reusable workflows. You can also configure the behavior. There's a bunch of stuff in there, background, foreground, how you want to render the output. You can do custom rendering of output, so you get a fully rendered table and a bunch of other stuff that will show you. And then some cool stuff with dealing with the process. So I guess the key features are you can create full-blown interactive workflows in Markdown, check them into your repo. We can add metadata to make them even more useful and track things like what your session looked like over time, and store that in local files so that you can go back and view your historical sessions or share them with people. You can configure how those commands get executed, name things. You can run cells in any language that is interpreted, basically. And then we have a bunch of cool cloud integrations so that, for example, you could run a URL into GCP or into GKE and actually get a fully rendered cloud UI inline in your documentation. And then VS Code, of course, offers a whole bunch of cool configuration around formatting and rendering, right? If the output of a command that you run is actually an image, why not just render an image, for example? And you can install a number of other extensions in the VS Code marketplace. I think one's called DataViz, where you can do cool things with sortable tables and stuff like that. We also have some tooling to help you define and validate the .env that you're building out, so you can visually see what all the keys are in your environment and whether those are, you can actually add types to your .env file if you want to. Then it can tell you all the things that you're missing. And being part of the VS Code ecosystem allows us to run a lot of places, all those IDEs, but also in code spaces. You can also run your VS Code server in, for example, a pod in Kubernetes, and launch into that in your browser. Now you're executing commands inside that environment if you want. And sort of the last thing is, so you spend all this time making sure that these workflows do something important. They're checked into your repo. You have all this context around how they're supposed to run, where they're supposed to get keys. Why not actually just run those or some subset of those in your CI environment, right? So you have a pipeline, and you can say, go run my, set up a pod configuration and tell me if something that we did in our infrastructure as code or something else actually broke that, so that the next person who finds it can continue to have a good experience. So you can kind of see here the way that we think about this is you have your Markdown documentation. A lot of the things that you may want to do on a sort of a day-to-day basis, and a lot of places you may want to do it is possible. Then also test the stuff inside of CI/CD and then deploy, right? So you don't. We are not asking you to change how you think about your GitOps process at all. Just trying to make it a little bit better. So this is a little bit what it looks like. There's a framework called BATS, and it's basically doing an assertion on commands that you're running using the Runme binary. I will just pop out really quick here. So you can sort of see this is a BATS file. Here is basically a test case. This is verifying the kubectl version. Yeah. So this is for the Linkerd website repository, and in the pipeline, the basic idea was, let's use the documentation that they offer to anybody trying to use their CLI as basically a set of test cases, so that anytime that there's a commit, this goes and runs, right? So we set up the environment, we import the bats helpers, and then see this is sort of the flags for how we want to use Runme and the command to run that. And then you can see here's the definition of the test case, and then we run it, and then we do some assertions on the output. And we do this for almost all of their initial getting up and running documentation, and it works really well. So you can sort of see this running in GitHub Actions. So we sort of feel like we've struck a chord with this concept. People seem to want to do better with their documentation. We're approaching 60,000 installs on the VS Code Marketplace. We have a lot of people in Discord. Very few of them are doing very much, but a handful of them are in the help channel and actually getting things up and running, which is cool to see. We have about 17,000 monthly downloaders, and we use a cool tool called Scarf. If you haven't checked it out, it's a great way to get metrics for open source project usage without being super invasive, which is sort of showing around 4,000 companies represented in the data set there. So it seems to be solving a problem people care about. So quickly, I'm going to go into a fairly straightforward demo, so you get the idea. Is this big enough to see? Oh, yeah. Okay, cool. All right, so this is just a GitHub repo. We're in the README.MD. Other than some optional metadata up here, you probably see that this looks like, basic Markdown. I'll jump into here as well. Other than having an ID here, also optional. You can see that this is basic Markdown that will render in GitHub or any other place that you wanted to. Actually, if we go to open the preview, don't know why the background is weird like that, but you can see that this is just Markdown. This is probably theme related or something, but we didn't build that. So first step I'm going to do is go into the extensions, which is here. All right. Search for the Runme extension, install, done. And now that Markdown file that I had, let's get out of these and go back to the main index. That main README, these become rendered notebooks. There's nothing particularly exciting about this one other than that it's hyperlinked to other things. I'm going to spare you the configuration of AWS. You can just assume that I ran all these commands yesterday. So when I go and run a command, you can see that on the side of it, we get this nifty little play button with some configuration around prompting for input. So you could say, don't automatically set these environment variables, ask me for them. You can also see that there is a configuration tab down here. It has to do with interactivity and prompting and running in the background and MIME types and all this kind of great stuff to just sort of make the experience better. When you make those changes, that stuff is encoded back in transparently into the Markdown file so you can check it in. But otherwise, you probably won't know it's there. So let's see. Let's set up the count. Don't look at that. And here's sort of the first thing that's a little bit unique. So this is a URL into the AWS console, right? And these are my clusters. So when I run this command, normally this is fairly meaningless, right? But what we actually do is we go generate a UI and embed it right there in line. And this is pretty fun. So if you want to break this file out and have it running in a separate window or a separate sort of tab, you can then go do things like apply run a bunch of new containers, right? And you can see changes sort of in real time in the UI rendering there. All right, so let's keep going down the list. You can sort of see how simple and straightforward this is. Switch to context. All right, so what pods do we have? Okay, so we have some pods going. All right, so our environment is set up properly. Let's double check our version. Okay. Make sure this is set. All right. Part of getting our pods. All right, and so we have an application here called Emoji Voto. It is defined here in this YAML. The basic idea of the application is that you can vote on your favorite emojis. So we'll go ahead and apply that. Okay, so you can see our pods are being created. Simple command to forward the port. And let's see if we can start voting on emojis. Okay, so basically the idea is that everything should pass except for our favorite poo emoji, which is a 404. All right, so we have this up and working. Click through a bunch of that stuff. There's a button here called Run All. And so these things can either be run, let me reset this so you could see, reset. Okay, so these things can either be run synchronously or asynchronously, depending on what you want. For this case, I'm going to run them sequentially, and we'll see we're curling our endpoint. The basic idea is, right, if you could do this, of course, in a script, but if you want to just run one of those things or you want to run a particular command from the CLI, it's nice to have sort of what your debugging process looks like codified. And so, right, we get to a place where we should, that one will pass, and we get a 500 for the donut. So that went pretty quickly. So now we have clarity about what happened there. We can go fix it, rerun all these commands, and basically get sort of a local pipeline test results. So I got the thing up and running fairly quickly. I mean, I got clarity around whether it worked or not. I could go fix it. And then one of those things about trying to save cloud costs that's nice is having a really easy way to tear down infrastructure that you put up, especially if you're working in devland. You don't want to leave that stuff, well, especially if you have a lot of people on your team bringing up infrastructure. You want to shut that stuff down and not have it running all the time without having someone on your team be a janitor. So I've outlined sort of a process here, which is going to kill that port forwarding, and then I'm basically going to delete Emoji Voto, which would shut down all my pods. So okay, and boom, now all that stuff is getting terminated. And that's fairly quickly how you get up and running with sort of all of the different facilities for running and working with a simple use case. So I'll come back here. All right. So how does this work? We have a couple of code bases. One is the Runme code base, which is it's the Go interface. It's a little server that runs. You can also connect to that from basically anywhere you want. It's just a server. We also have the VS Code repository, which is mostly TypeScript, which is what gets published with the binary as well. The thing in the middle here we call the shell terminal. That's what serializes and transforms the markdown. One of the important nuances is that if you make changes in the notebook and you save that, that gets serialized back to markdown, and the other way as well. So you don't have to think about where you made your last set of changes. Let's see. We have the portable runner interface, which I talked about. The stateful kernel. So if you, one of the positive things is that each of those little outputs is where the commands go. Each of those are basically little terminal sessions, right? And so if you're setting environment variables, you can actually access that from the next one, so you don't have to set things up from every step, which is one of those frustrating things in test environments. Raw Markdown editor, and then it's also nice to be able to do a lot of that stuff visually. That's kind of the core concepts. There is a bunch of advanced stuff here. So if you are interested in using Dagger pipelines, we've done a bunch of work to make it really easy in here to run through your Dagger function or your Dagger pipeline on VS Code. So once you open once you start interacting with the Dagger CLI, you'll see a bunch of value added in there. There's a fairly new big launch, I think, coming out soon that we've done a bunch of work on. You can also use Runme inside of a dev container. So if you want to sort of package things up a little bit more tightly, there's a bunch of great blog posts that we've written about best ways to do that. Recently, we added the ability to render mermaid diagrams inline, which was very popular by demand. There's also, in the same way that you saw Cloud UI rendering, you can also render a GitHub Actions UI inline, so you get the nice buttons for doing deploy and to which environment. Running cells by tag, so if you name and tag a bunch of this stuff, you can say just run the setup steps, so it's a nice sort of little task runner. We also give basically a button click to push either the whole session or a part of the session to a gist in case you want to share output. If you're maybe doing a shared debugging session with your team, here's what I ran and here's what came out of it. Those cloud renderers, which we have for GCP, for Google, Amazon, and Azure. And then, of course, if you want to use Runme over with a VS Code remote SSH session, so you can use VS Code to connect to a remote box and run Runme there. Okay. There is another very cool project that is important to know about. And an engineer inside of OpenAI named Jeremy started working on a project called Foil.io. Foil is very cool. He did a great talk at KubeCon in Salt Lake City, if you're interested in watching that. But the basic idea was, how do we use LLMs with Runme interactive notebooks and have them collect context and then help you and other team members write and execute this interactive documentation. So you can imagine, we actually have a playground online that you can go try this, but it's pretty cool. You could say something like, I don't know, I want to write a Python script that does X, Y, and Z. And it will start working on generating that, and then as you correct it, it's storing those changes, and then the next person who opens that notebook, they also get that context in line, so they'll know, the binary is called Python, not Python 3, for example, whatever it is. And it gets better over time as you use it. So you can sort of imagine where this goes over time as a whole team is training, building out this context that's used to inform the LLM. You could get to a place where you could basically go into a notebook and say, I want to deploy this service to a new environment. It's called blah, and have the thing mostly write it, including all of your infrastructure as code and all of that kind of good stuff, and then also help you debug it. So that is a very cool project that's worth watching. So where are we going with this? So recently we were voted into the CNCF sandbox, which I think is going to be really useful for both visibility, but also having folks to interact with to decide what we're going to do next. There's a bunch of stuff we want to do around SaaS integrations with other services, adding more shells, working on Windows. Currently you have to use WSL. Doing smart things with front matter, doing smarter things with secrets. There's a whole lot of really cool stuff that can be done, and we're working on that, of course. And then I think the last thing I'll show you here is if you go to Runme.dev, you can actually click a button that launches a Runme sandbox, so you can go start playing with it. This uses Knative. You have to sign in so you don't, oh gosh. So we just load a VS Code environment there inline in the browser, and you can start to play with it. You can also do this for the Foil project if you want to see what it feels like to sort of train a notebook interface. That's pretty cool. So we tried to do the theming here, of course, and all that. If you're not familiar with how the VS Code ecosystem works, it's all web tech, so it's very cool and extensible. Well, internet. But in here, you can actually go through a whole bunch of different sets of markdown files that you can play with and sort of see what happens if you configure those smartly. Also inside of our documentation, we have tons of guides for how to configure and use Runme, and answers a lot of questions that you might have. I don't know, this is rough. Okay, well, you get the idea, and I hope on your connection it's a little better. Also in Discord, we've got a bunch of community stuff there. We've got a lot of people who are willing and interested in answering questions. So if you want to join us, we would love to have you. And if you want to hack on Go or TypeScript, we'd also appreciate all contributions. And that is kind of the scope. I hope it gave you the idea of what this thing is and why you might care about it. And I'd be happy to answer any questions that anybody has. Thank you. Yeah.
So does the Runme executor, the thing, run locally on my machine, or is it only cloud hosted?
Yeah. So by default, there is a Go process that is running inside the extension host. It's in VS Code locally on your machine, unless you are running the VS Code server in some other infrastructure, right? And then you can use that endpoint and execute in a different place, or over an SSH connection. Yeah, so they're basically literally little terminals running on your local machine by default, but doing some extra magic to make sure that the environment variables are passed down through each of the terminals you're using. Yep.
That past example that you had with TypeScript is pretty involved. How much of that is boilerplate versus how much do I have to recreate the packet?
You should repeat that for the video.
Oh, there's a video. So the question is, how much of the BATS example of using Runme in a pipeline is boilerplate and how much of it you have to create? So the Runme CLI, you just use Runme run, and you can say a file and or a specific command. And so BATS is just, kind of one of the first things that we found to be fairly straightforward for asserting output from running bash commands. We have a get of action that we've built for Runme that tries to make this simpler, but we did that development to use BATS, right? So it's a custom shell script, but there is a whole on our blog. Let's see. Actually, I think I have a link to it here. Oh, that's to the example. That's the Dagger one. Well, there down here, probably not too far, is a full-on blog post that will walk you through every part of getting that set up and running. But you could basically use any assertion framework that you wanted. And to be honest, if there's stuff that you specifically want, like frameworks or tools that you're using, here we go. We'd be happy to hear about that and try to make them better. Here we go. Yeah, so this will give you a full walkthrough of how to set that up. Of course, that's where that screenshot came from. Yeah, so it'll walk you through the whole BATS thing, how to do setup and teardown and everything else. It should be fairly straightforward.
Could you go into a little more detail about foil?
Yeah. The question was, can we go into a little bit more detail about foil? So this is foil.io. There's a very cool demo here. I'm going to mute Jeremy for a second. But I would suggest you check out his talk at KubeCon in Salt Lake City. But the basic idea is that you open one of these notebooks. There's a service that, let's see, how does this work? So as you're interacting with it, all that metadata is being stored in an in-memory sort of vector database conceptually, right? And of course could be written to, Pinecone or something else. But as you're interacting with it and making changes, it's using that context, sending it to an LLM with what's going on here, and then rendering cells, which we call ghost cells, sort of like ghost text in an editor, and generating new cells based on that, on what it thinks that you may want to do next, and or what you're trying to get it to help you do. And his examples are all very cool because, you're interacting with things like, running a set of SQL commands and trying to find a particular piece of data, and or you're trying to debug an error that's happening somewhere in your infrastructure. And it does a really good job of learning from that and then helping walk you through that process and then getting the thing deployed again. So really neat conceptually. Yep.
Can you, one thing, can you run two commands parallelly within the notebook? And if you can, then how does the output come out? Instead of like, how do I know which command has what output?
Yeah, so let's see. Right, well, this will all fail now, but maybe I can get this up and running really quickly again. Let's redo these and set up the port forwarding. Okay, so let's clear this with a reset and run all, run in parallel, and you'll see that each of these just get their outputs in their little terminal when they get them. Right? So, of course, if they're dependent on each other from top to bottom in the command, you can run sequentially, but you can also just say run all the things, right? Which is great for some use cases.
And because I see the save buttons on each of the cells, is there a save all?
So what you can do is you can turn on this thing called autosave, and I can just show you really quickly. Oh, sorry, the question was about running sequentially versus in parallel and what the outputs look like. So now if I run this, what we should see when this finishes. I wonder if that worked. Autosave is on. Oh, this might be a different a demo configuration problem here, but the basic idea is that when autosave is on, you should be seeing markdown files being generated in the directory there that shows everything that's happening in your session, right? So you can turn this on, and as you're going and doing your thing, you're building up all this stuff. You could check it in, or you could gist it, or you could share it with somebody. So, yeah. I'm not going to try to debug which config I have going that's making that not work.
So the output of the commands that's going into the individual is also being saved?
Yep, if you turn autosave on, that's all saved into a markdown file. And then I think you saw here, let's see if really quickly I can do a reset. Looks like the process doesn't want to do that. And all. Okay, so I have some cloud stuff turned on here, but here, preview and gist. Right, so you can see the idea that inline this stuff is all being saved as it runs, and then we mask by default stuff that might be sensitive, and then you can go from there and log into GitHub and generate a gist. Does that make sense? Yeah?
I can see it all says bash here at the right. Do you also support other languages?
We do. Let me... the question is a lot of the default stuff here, because it's sort of a DevOps workflow, is bash, but do we support other languages? And the answer is that yes. If you go to our docs here, and usage, let's see, where's the list? Here we go. So you can see Python, Ruby, basically any of the interpreted languages should execute. Here, if I execute, this is Python, of course. So if you go into the configuration, that might be auto-detected. You can also specify where the interpreter is that you want to use to run it. So you can do a bunch of really cool stuff with that. Yeah. Anything else? Yeah.
Just one thing, a comment, is you mentioned you want to do the Windows. There's already an extension called Polyglot from Microsoft called Polyglot Notebooks. It does PowerShell, that, and other like kind of .NET languages.
Okay.
But yeah, so that's already kind of covered.
Cool. Yeah, I mean, I know we have a bunch of folks using it with WSL, and not everything is perfect, but should explore that to expand that a little more. A lot more to do. And also, right, you see that there was nothing from the JetBrains IDE family here. I'm sure that with the popularity of Jupyter and things like that, notebook interfaces will come. And so hopefully either us or someone in the community can go do some development to make this work the same way there. Awesome. Cool. Well, I hope that was helpful. I appreciate all the questions, which were great. And I hope you all go give it a try and come talk to us on Discord. Yeah. Thanks. Thank you for coming out. I hope you had a good SCaLE.
That's it, probably. Hey, Marco, do you want to give me your remote? Okay, I'm gonna come on. Is it? Yeah, I mean, it's such a small group. I don't think we need this, but they are streaming it apparently. So, I don't know if somebody from the staff has to come in. I don't to like start it.
It starts at 1:45.
Yeah, yeah. You guys having a good conference? Yeah. You catching a lot of talks? Yeah. What are you all most interested in? Anybody?
Knicks, it came from the Knicks, John,
Oh, nice.
but also some video about a EPF,
Oh, sick.
and it's really useful.
Yeah. How about you?
I do, so I work on platform for a company that does kind of Gen AI for videos.
Oh, cool.
So I'm interested a little bit on the different aspects of it because there's like, the training and the inference, but there is the developer experience.
Yeah, yeah. Nice. And it's a developer platform you're working on, or no?
Oh, we have a product that is for like
Oh, okay.
video, Gen AI for video.
Oh, I see. Okay. Nice. Yeah, I'm not going to go. This isn't a super technical talk. This is more of a I don't know, not really a business talk, more of just a vibe, I guess. But if you want to sit around, or if you want to stick around afterwards, we can talk more technical. I have my coworkers here. Here's our VP of product, our DevRel, and one of our product managers. So they'll be able to answer any questions that you guys have if I don't know them. How about you in the back?
Mostly going for observability talks.
Oh, nice.
Updating our stack of like
Oh, nice. Did you catch the Dave McAllister's talk yesterday at the end of the day on stats, the stats behind observability and things like that? That was a good one. Yeah. Apparently, I was the inspiration for that talk. Yes, he even said it during the talk. He's like, "Oh yeah, oh, geez, I'm flailing around here." Yeah, we were sitting around one day, and really, like that. Yeah, we were sitting around one day. We used to work together, Dave and I, and we were sitting around one day, and I was like, that's a really interesting slide. That could be its own talk in itself. And so he made it into a separate talk, and he claims that it's been his most popular talk ever. He's given it like 47 times or something now. I'm not making that. It sounds like I'm pulling that number out of thin air, but I'm not. He actually said that. So I'm just going to try to do this. I feel like I'm a Secret Service guy here. Hopefully that'll keep the wires out of my flailing hands. You know what? Actually, I'm going to do this. If bet the people on the live stream are getting a kick out of this. Yeah, there we go, that's better. That's much better. Find somewhere to clip this. Marco, is this mic in a good position? Okay. All right, we are right at 1:45. I'm assuming there's no proctor coming, so I'm just going to get started. They're probably already heading over to the keynote. So thank you everybody for coming today. I know this is the end of a long grind for this weekend. I'm really glad that I have more audience members than coworkers. So that makes me very happy. But we are recording this. Of course, it's being streamed, and we're recording it for our content as well. So if you read the abstract, you know this one. Today I'm going to talk about cloud development environments and how they are strategic assets. We'll go through a few things. So just a raise of hands. Has anybody here deployed a cloud development environment at all? Not you guys, but you have? Okay. Are you guys familiar with what they are? Yes? Okay, one, and a couple people just are completely not familiar with them. Okay. In a sense, yeah. The IDE is a component of a cloud development environment, but yeah, we'll get into it. I mean, I have a couple slides that talk about what they are, and the strategic benefits is the main part of it. But we'll have a bit of an intro. So we have a timeline. Actually, let me just set a timer here real quick so I don't go over. Okay, so basic timeline from, before this little hash in the middle or towards the left side, that's going to represent day 0 of when a dev starts on, first day on their job, first day on your project, whatever it is. So before they start their work, you have their hardware provisioned, you get all their authorization and authentication set up and everything. They start, it's day 0, and then they are handed essentially a treasure map, maybe half of a treasure map. There's a corner torn off. They have to go dig around. Maybe it's like the Goonies over here. We were talking about that earlier. They are on basically a treasure hunt that's a circle of discussions and dead ends and telephone calls and who knows what it is to get their environment set up, right? How many wikis are they reading? How many IMs or how many DMs is it? How many emails is it? How many security requests? Who knows, right? Then at some point in the future, they've reached their goal and they have a fully configured development environment and they can commit code into the repo. So what if we could cut that middle part out? Before the dev starts, we do the same motions. We provision the hardware, set up all their auth, day 0 for this dev, and then immediately they're at that target. It eliminates all this friction in the middle of them having to hunt down everything that they need to do their work. And that's what a CDE is. So if you take nothing else away from today but these 3 things, CDEs are a way to enhance productivity. They ease compliance and improve security at the same time. So you can reduce developer friction and have a safer environment and a safer product from that. And ultimately allows you to ship your code faster at scale, right? If you're a small, very agile shop, shipping code fast is not a problem. But if you're a big shop and you're constantly hiring people, you're bringing in contractors, maybe you're offshoring some stuff, shipping that fast at scale can be an issue. So today, the agenda, we'll talk about Coder, the company. We are a company. We do have employees and we do make money, but this isn't a pitch, right? But we'll talk about the company a little bit. Then we'll talk about what is a CDE, what the developer experience with a CDE is like. Then we'll talk a little bit about security and compliance. And then we'll get into the meat of it, and that is the CDE maturity model and the developer golden path and how they're intertwined. Then I'll have some resources for you, and then we can do some Q&A. So, Coder the company, we've been around since 2017. We're still funded. We're in a Series B2 right now. We're finding great success in, the Fortune 500 and government and things like that who are purchasing our product. But we also have a lot of small projects, using our community edition. And, our thing is to keep developers in flow, right? That's our mission, period. These are some of the companies that are sort of our marquee logos. You can see there's some pretty big companies on here, some pretty security conscious organizations as well. We also have some government agencies too that are our customers that we can't really name. But suffice to say, it's a really secure way to develop. And we are an open source first company. All of our stuff is open source, period. Even the premium features in our product, you can see the source code for them. We have 125 repos in our GitHub right now, and most of those are related to our flagship product, which is called Coder. We have an aggregate of about 95,000 stars across all of our repos, and we're shooting for 100,000. We hope to get there pretty soon. And we have a really active community as well. We have over 3,000 people on our Discord server. So even if you are using our open source community version, you'll still be able to get some decent support and have some help there. So what is a CDE? It's a way to abstract everything a dev needs away from their laptop and put it up in the cloud. So it gives you, it's a predefined workspace that's decoupled from your machine. It's in a cloud somewhere. That cloud can be on-prem, it can be public. It doesn't even technically have to be a cloud. We release OS packages for, we release RPMs, Debs, Alpine packages, so you could install it on a server if you wanted. But we typically just say cloud, just to gloss over all that. And the CDE provides a comprehensive set of tooling, right? It's all the compilers, the libraries, the IDE, everything. It's all prepackaged and declared in this workspace. And it also provides the compute resources as well. If you think about in Kubernetes, for example, you could define a workspace as a deployment that pulls a certain image. At runtime, it installs a certain extra packages. Maybe it downloads the developer's .dot files from GitHub, and it defines what node that it's going to land on, and how much CPU, RAM, GPU cores, whatever that developer is going to get. So that's what we mean by it defines all the high-performance resources. It's like infrastructure as code for a workstation, basically. So we all know how devs code today. They have either they're working on their laptop, or they're working on some kind of VDI, or maybe there's some shadow IT VM out there that people are logging into, and who knows? There's problems with all those things, and I won't go into all the detail on that. I'm sure you've seen those problems happen more than once over the course of your career. And then eventually they push all their code up into a CI/CD, and then it gets deployed at some point somewhere. The thing is here, everybody's writing cloud-native software nowadays, but the developer experience is still on a laptop, on a VDI, or on some random VM. There's no real integration with the cloud flow. With a CDE, you're removing all that tooling and more importantly, all the source code off of the developer's device, and you're moving it up into a cloud instance, and they're just going to access that with their IDE. And that could be a browser-based IDE or any local IDE that can do a remote connection. And you see that the CDE gets moved up there with the CI/CD and the deployment flows. So an ideal CDE, it's going to be standardized and reproducible, meaning that every developer workspace is going to be declarative, right? So that means that every developer who starts up a workspace from that same declaration is going to get the exact same tooling, the exact same hardware that their coworkers are getting. Everybody's going to get the exact tooling that they need to build the product. You're not going to have any, somebody using an old version of a library that causes a regression or whatever. It's secure, it's scalable, and it's stable above all things, right? And by stability, we not only the platform stability, but that stability of every dev getting the same thing. Therefore, the product that you ship is going to be a lot more stable, a lot more secure. And ideally, it should follow open standards and be able to integrate with your enterprise. When you have a developer platform, the last thing you want to do is have to recreate a wheel or have to certify some new way of doing something that you're already done certifying. Like say authentication for some reason, right? You already have OIDC, you already have a SAML, whatever it is. You want to be able to use that instead of having some other method. But you can think about all the other systems that you integrate with. Your CDE should be able to integrate with those as well. So the DevX, when using a CDE, it's pretty straightforward. Like I said, their environments are pre-configured. Ideally, it's a declarative template. It's not anything binary or anything like that. So it's human readable. You can modify it. You can keep it in the declaration in source control itself. Something that's pretty straightforward. So they spin it up, they connect to it, and they start coding. Just like that initial slide I had with the map and the second developer starting up on day 0, being able to commit code. So, like I said, this is not a pitch, but I am going to show you some screens from Coder just to give you the idea of what a CDE can look like. When the dev logs in, this is what they see, right? There's no desktop, there's no command line that they're connecting to or anything like that. It's just a web UI, and they have a couple of workspaces there running. So they'll go in, they'll click into one of the web spaces, and now it'll give them the options to connect. This guy can connect with VS Code Desktop, with Code Server, which is another one of our open source projects. It's an implementation of VS Code that runs in a web browser. Or they can just connect with a web terminal. Now, like I said, any IDE that you can do a remote connection with, you can connect with Coder, and then any web-based IDE will work as well. So basically, they click on that VS Code Desktop. This pops up. It's a separate window from the normal VS Code that they're running. It installs an agent, and that agent connects to the control plane and then negotiates with the control plane and the workspace on the back end to get a peer-to-peer connection, and away they go. So it's really straightforward. It's really simple. The devs don't have to have a big fancy computer. They could use, anything with a Chrome browser will work. They could even do it on an iPad if they wanted, right? If they obviously won't be able to run local VS Code on an iPad, but they could use the web-based one if they wanted. So the way that these can improve DevX and productivity, like I said, they can access from anywhere on any device. As I said, they don't have to have a specialized workstation. Any laptop will do. They can commit their code on their day 0. We have one fintech company that had a 3-week onboarding process, and now the very first step in their developer onboarding guide is log into Coder and create a commit in like the hello file, right? So they log in, they got all the tooling, they're connected to the repo, they have everything they need, and they're ready to go. And it also provides that consistent pre-configured environment. Everybody gets the same thing. Everybody gets all the tooling they need, nothing more, nothing less. The lowest hanging fruit with a CDE, and if you can just achieve this, you're going to save time, you're going to save money, but there's a lot more to it beyond this, but this is the lowest hanging fruit. If you look at the top line, a dev's got meetings, configuration, and that means configuring their environment or their machine somehow, keeping that in compliance, and then code reviews, code maintenance, testing, whatever. And then they have this small little slice on the end where they're actually coding, right? Some bigger companies, the devs are only coding like 10% of the time, right? If they're lucky. With a CDE, if you can just cut out that configuration and compliance and just leave them with their meetings, their code reviews, maintenance, and testing, that's just more time they get to spend coding. Is it double? Maybe, maybe not. But this is just a really simplified view of it. So the bottom line with DevX when you're talking about a CDE, more time to code, right? It's that simple. The more time the devs have to code, the happier they're going to be. The happier they're going to be, the less they're going to churn. We've had some clients say they've spent all this money recruiting people from top schools, and it takes them 6 weeks before they can even commit a line of code, and the guys walk out the door because they're bored after 3 weeks. They want to be writing code. They don't want to be filling out security requests and things like that. And it just accelerates time to market. So these are pretty straightforward, pretty easy to understand. Security and compliance, we'll talk about this for just a few slides really quick. Lost productivity isn't the only risk, is what we say. There's code exfiltration vectors all over the place, especially when you're dealing with contractors. A laptop gets stolen. Is the hard drive encrypted? You hope so, but maybe it's not. Who knows? If the devs are configuring their own desktops, their own laptops, who knows what they're doing? Somebody gets up, walks away from a coffee shop, walks to the table to a coffee shop. Somebody snags a laptop with an unlocked screen. It doesn't matter if that thing is encrypted or secured or whatever. They can just change the password right then and there, and then run away with it. So. Yeah, the security advantages, I went into the first one here, physical loss and misconfigurations. That is you eliminate all of those vulnerabilities and all those attack vectors when you're using a CDE. You integrate into your enterprise accounts. You're already using your centralized ID providers. You can set them up for a least privilege model. You can use vaults for secrets, things like that. All the stuff that you're already doing with all your other platforms and all your other systems, you can now apply that to your dev flow as well. And you secure your supply chain. You can configure it so it only pulls from vetted repos. The images are scanned and everything, and it's just a very secure way to build their environment. So when you are thinking about a platform like this, there are some considerations. What's the distribution model? Is it open source? Is it proprietary? I would assume everybody here, just the nature of where we are, they're going to want something that's open source. Something you can host. You're not reliant on a SaaS provider. Some people, some of the SaaS products out there may suit them, and that's fine for them. So you just have to look at the landscape when you're selecting a CDE platform, because there are options all over the place out there. You want to look at who's hosting it and who's managing it as well. We have, like I said, we have some very highly security conscious customers who they wouldn't dream of running a SaaS or allowing a vendor to support something. They run it in an offline data center. They do all the support. They do all the hosting. So it's a range, right? It's a complete range, everything from SaaS to air-gapped and offline, and everything in between. There are options out there. And how are you getting your new platforms and tools vetted, right? If you have a platform that, like I said in the opening, that has its own wheels, right? It's recreating wheels. Now you have to get all that stuff vetted to be able to be used. But if you have something that just stands on its own and integrates with what you already have, that's just less security certification that you have to do. So the bottom line, these are centrally managed and governed development environments, and that makes them more secure by nature. You're minimizing the threat of supply chain attacks, and it's safe onboarding and offboarding. Think about it. If you have 500 contractors from who knows where, and now all of a sudden they have all your source code on their laptop, they have all your documentation, and one of them leaves. One of them, absconds in the middle of the night. That could be an attack vector. With a CDE, basically, you want to offboard somebody, you just shut off their access, and they're done. They're out. So that was the basics. Now we'll talk about the maturity model and what we call the golden path. So show of hands, are you guys familiar with the term golden path for developers? Okay, a couple of folks, about half the folks, that's great. So it is a big deal. It sounds kind of weird when you first hear it, like, can it really be that important? But it is, and it has a lot of big benefits too. So the golden path, it can be broken down into these three aspects. It's a prescriptive set of best practices and tools, right? And it helps guide the developers in an efficient way to become more effective, right? That's one thing. It's curated and it's opinionated as well. You have to say, we are going to standardize on this set of tooling. Now, you might let them use a different IDE or something like that, but the core stuff where you're building, it should all be standardized. We can't say as a broad statement or a cookie cutter statement like you should use this OS or this compiler or whatever. Those are decisions you have to make. What works best for your org? What do you think will make the golden path most effective for your devs? And it's a continuous journey, right? It's continuously refined. Every time you iterate on your golden path, it should make the development experience more robust and reduce friction for your devs, right? And then the maturity model. This is a thing that we published a few months ago. It's a slightly tweaked version of a capability maturity model. So it has 5 stages: the ad hoc stage, the foundational, defined, refined, and optimized. As you go through these stages, you're constantly working on your golden path, constantly working on your CDE delivery. Everything's incremental, so each stage is going to build on the previous stage. There's going to be more automation, more self-service, and just a smoother flow from stage to stage to stage. And then the CDE maturity model, or CDE maturity in general, and the golden path, they're intertwined, right? The golden path defines what each stage should do or each stage should be, and then that stage enables the next iteration of the golden path, right? So it's more of just a cycle that keeps going. It's a never-ending cycle. Even once you get to the 5th stage, you're constantly going to be iterating. They're going to be smaller increments, but it's something that is going to always keep moving. So this is it. This is an eye chart. I apologize. We will dig down into this, but I just wanted to show you that these are things that build up on each other. And I mentioned that this is a slightly modified version of a capability maturity model. And what I did, a typical CMM is technology, people, and processes. But I broke the technology into 2 things, one for tooling and one for infrastructure, because they are important to look at on their own. So we have tooling, infrastructure, people, and processes. We will dig into each one of these in the next few slides. However, at the end, I'll have a list of resources where you can download the paper that we published on this model. So, considerations for each stage. Whenever you are either embarking on a stage or you're completing a stage and you're in between, you always want to understand what your current state is. Even if it's a mess when you're getting started, you want to know what that mess is. And then as you move along in the maturity model, you're having more, breakthroughs or more traction or more adoption, and that can bring its own problems. So you want to align your technology, your dev experience, and your processes for each stage. You want to have them sort of balanced, and you want to progress them all equally as they go along. And you want to have incremental milestones. That could be milestones for each stage or milestones within the stage itself, right? You guys know your devs the best. You know what they're going to need to get to, the end of a stage. So you have to set it up to so they can do small changes incrementally. So stage 0, ad hoc. This is essentially anybody who's pre-CDE, right? These are the people who are looking at it and thinking of a POC. So the current state, and now I present a very worst case scenario here, of course. I mean, I would hope even if you don't have a CDE, you're in a better state than this, but this is just a worst case scenario. So there are no standards, or vice versa, there are many standards, right? So, if you have 14 standards, do you really have standards? Who knows? Things are inconsistent, and there's friction at every step for the devs. This is that map I showed at the opening where, you're basically handing them half of a treasure map on their first day, and it's up to them to figure out what they need, who they need to talk to, what they need to get installed to actually do their work. And the golden path in this stage doesn't exist. Things are risky. You have an attrition risk, security risks, things like that, and it can be very expensive, especially if your folks are using shadow IT. If they're spinning up VMs with GPUs on them and leaving them run 24/7, I mean, that's buku bucks right there. So the goals for stage 0, you should be able to inventory and assess where you are. And you should be able to select a pilot team for your CDE pilot. Now, this team could be the team that has the best abstraction or the best standard out of all of them, or they have the easiest use case, or, it's really up to the platform team, as people who are providing a new platform, to determine that. And you have to realize that at this stage, there's a division between the dev's workflow and technical debt. There might be, my friend Carl, who, he's not here right now, I thought he was going to be here, but he has a phrase that I love. He says load-bearing technical debt, right? So you have however you want to define your technical debt, that if you try to eliminate that, the house of cards falls down. So, stage 0, you're taking a long, hard look in the mirror, so to speak. So stage 1, this is what we call the foundational stage. And the goals of this stage are to set up a proof of concept and a minimally viable platform, right? Something that can be used, but it's far from perfect at this point. It should be on a supportable infrastructure. It might not be on your, top tier, internal cloud, brand new machines, this and that. It might be on some repurposed hardware, or it might just be on VMs, or who knows where it is, but it should be something that the platform team can support, right? So we're getting rid of the shadow IT. We're getting rid of, people SSHing into each other's computers and whatever they're doing all over the place. And really, stage 1 should have one project or one team on the CDE. There should just be one pilot team. And the golden path now, it's starting to form, right? You're in the foundational stage of your golden path. Even at this point, small iterations and scoring are key. So you have to start thinking about how are you going to measure these changes, right? And the smaller something is, the easier it is to measure, and the easier it is to score. And you're starting to look at standardization. So, you have those 14 standards out there. You've grabbed the best one, say, and now you want to iterate that until it's perfect, and there's no technical debt, and new people can jump on that project, jump on the CD, and be coding immediately. That's kind of the end state that you want. There are some risks with the early stages of CDE. If you go too fast, it becomes unmeasurable, right? If you were taking these big leaps and people were saying, oh, I want that, I'm going to move my stuff over there right now, it's a little too much to measure. And they're probably bringing technical debt with them, right? They're probably bringing technical debt into the system, which is going to cause a compounding effect that there is going to be technical debt with the CDE itself, not only with the use cases. And there's a risk here that if you stagnate at this stage, that you're effectively going to backslide to stage 0 because, and I use the number 14, and can anybody guess why I use the number 14? For standards? Yes, right? So, you know, if you have 14 standards and now you have a CDE and you stagnate at stage 1, you're in an XKCD cartoon. So, you know, it's just another abstraction, another way to do things, and it's not going to be an enterprise-wide thing. So, stage 2. This is where the CDE starts to be like a real thing. The goals for this stage are to get it on a supported and integrated platform, right? The platform in stage 1 was just something that was supportable. Do you take your stage 1 CDE and integrate it into all your other systems? Maybe, maybe not. Maybe you knock it down. Maybe you knock it down and start over because you want to get rid of some of the mistakes that you made. It's really up to you. Everything with a CDE should be declarative, though. Even the CDE itself, you should be able to declare in YAML files, config files, and database dumps, and be able to reproduce it, at ad nauseum, and not just the workspaces, the actual system itself. Conversion patterns are starting to emerge in stage 2. You've gone through stage 1, you've iterated that pilot team's workflows. Maybe you got 1 or 2 environments for that pilot team in stage 1. They're happy. You have a conversion pattern that's emerging that you can apply to other use cases and other development teams. And now, stage 2, the goal is to have multiple projects and then options for alternative use cases. So CDEs are not just for devs. You can put any sort of technical worker on a CDE, data analysts, SREs, DBAs, you name it. Anybody who needs specialized tooling, specialized network connections, and you need that consistent experience, they're a good candidate for a CDE conversion. And some CDEs are out there, though, like Coder, for example, just to plug us a little bit, our workspaces can be any OS, right? We can do Windows, we can do Mac, we can do Linux. So you could even get some of your Windows devs into your CDE if you wanted. So now, stage 2, the golden path, we have guided self-service for your devs, right? The devs are working with the platform team to say, we need to get this tool installed, or we need more disk space, or we need to connect to this network, and the platform team's going to fulfill that for them and change those declarations and modify those declarations to suit what the devs are needing. Your DevX scoring model should be pretty well established at this point. That is something that is always going to, kind of like the golden path itself, the scoring model could be tweaked and iterated as you go along, but it should be pretty well established. And once again, we can't tell you what to do in your scoring model. That's something that you have to, you know your devs best, you can establish that. And you're reaching a milestone here in the golden path where there's 0 setup for the devs. They log in a Coder, I'm stuck in sales mode here. They log into the CDE, they click a few buttons, and within minutes or seconds even, they have their development environment and it's ready to go. There's no configuration or anything on their part. At this point, you have to start thinking about scaling the CDE because you have a few teams on here. You have multiple use cases. Some of them may be non-developer oriented, but you're starting to see some patterns here emerging, and you want to grow your CDE and you want to do it effectively. So at this point, you absolutely need to identify a process champion. So if your CDE is sort of a ground-up effort, if it's the devs saying, hey, we want to standardize everything and we want to do it with this CDE, now is the time to look for somebody in leadership to back you up, right? To say, these guys are doing a good thing, they're doing the right thing, and we need to get more people involved in it. If it's a top-down approach, like if you're at a bigger company and the C-level people say, hey, we need this CDE thing, they start the pilot, They need to get other groups involved. Your process champion may be, say like a staff or a principal developer who is, on one of the CDE teams or the CDE only teams at this point. So it's just depending on where you're coming from. You're going to need to have somebody with some juice to get your additional teams on there. And you're starting to define your functional goals here, both short-term and long-term. And by that, it's what do you want to do? How do you want to achieve a better NPS, or how do you want to achieve a better scoring? How do you want to improve your productivity? How can we do that? What things can we do to reach that long-term goal here? And now you can actually start calculating your ROI on it. You can model the productivity and the gains that you're making at this point, because you're going to have a critical mass on there, or a maybe statistically significant sample of your devs are going to be on the CDE by that point. So when we get into stage 3, now this is where it really starts getting good, right? The goals of stage 3, the CDE is the standard. It should be whenever a new person comes in, they should be able to just, a few clicks and go. Whenever a new project spins up, say somebody comes up with a new product they want to develop and sell, it should be built on a CDE before anything else. So maybe CDE should be the first choice. Maybe not the standard, maybe the first choice at this point. And you're starting to look at those, the 3 S's, the security, the stability, and the scalability of not only the CDE, but your dev teams as well. Like I said, the big advantage of CDEs is they can help you ship more secure code, more stable code at scale, right? And the platform team in stage 3 is going to start delegating. They're going to start stepping away from the CDE itself, and they're just going to be treating it as a platform that they take care of, right? They're going to delegate some of the tasks to like the lead devs on each team. They're not going to be doing as much fulfillment. They're just going to be focused on making sure the platform's running and backed up and reliable. And at this point, the golden path, like I said, we have guided self-fulfillment. The devs can make decisions on what they need, and then those can be fulfilled by the platform team, but there are other ways of fulfilling that we can talk about too. Your DevX scoring is getting more and more refined as you go along. And we have tiered workspaces, meaning, I don't know if you can read it here in the infrastructure section. It says tiered multi-cloud, multi-platform infrastructure controlled by the platform engineering team. So tiered workspaces are, it can be as simple as, your sort of lighter devs, say you have, some JavaScript devs or something, they're on CPU only nodes, they get a gig of RAM, something small, whatever, versus your AI ML developers who need, 64 cores and, a ton of RAM and GPU cores and all that other stuff. So you have places for these different use cases to land. You have a non-homogeneous hardware selections. So DevX scoring, like I said, this is not my forte. My coworker Nikki right here, he's going to be doing a webinar that you can tune into very soon on DevX scoring with DX. So that'll be really interesting. And I'll actually have a link to our webinar section in the resources if you want to keep your eye on that. But you know your devs the best. You're going to have to develop the model. But you can look at these 3 overarching categories: the technical performance, the developer sentiment, and then the organizational value. And whatever the components are that make those up for you guys, you can iterate on your scoring model. Right here, just some of the samples. Technical performance, we have time to first commit, time to 10th PR. That's those are 2 very different things, but very representative of what devs can do. And reproducibility. How quickly can you reproduce an environment to, say, work on a PR or something, right? With a CD, it's like instant. The developer sentiment, NPS scoring, their productivity ratio, how much can they self-serve? Basically, how happy are they using this developer environment? And then organizational value is what gets realized by all these other improvements. What's the adoption rate? compliance adherence, things like that. Like I said, not my forte, but tune in next month with Nikki and DX, and they'll have a whole big talk about that. I'm going to do a time check. We're at 37 minutes. We'll be out of here on time. So, stage 4, optimize. This is the final stage of the CDE, but it's a what's Simon Sinek say about an infinite game, right? You know, stage 4 is an infinite game. It's a never-ending stage. So the goals here is that the CDE should be the default, and I put an asterisk next to default because there always are going to be corner cases or edge cases where you're not going to be able to put them onto the CDE. So you can't mandate that everybody uses it, but it should be, you know, very highly critical mass. Over 90% of your devs should be using the CDE by stage 4. At this point, the devs can do their own workspace declarations with some sort of infrastructure as code motion. We use Terraform, so you know the devs should be able to write their own Terraform to configure their own workspaces, to select different hardware, you name it, different clouds, multi-cloud stuff, whatever. And support and integration are SRE motions at this point, right? This is an established platform. Your SREs or your platform engineers are treating it just as, you know, a service to keep up. They're not in the day-to-day with the devs helping them configure stuff. They're removed from that, and they're just making sure it's a reliable system that your devs have. And the golden path for this stage, it's fully established, meaning, you know, you should know where you are and where you're going with your golden path at this point. However, it is an infinite game. Right? Everything should be pipelinable, and this goes right along with devs declaring their own workspace declarations. You know, there should be some sort of a pipeline, so a dev can say, I want to try adding whatever, you know, adding some alternate network paths or some alternate hardware or whatever. They should be able to put that in a declaration, put it into a pipeline, and have some sort of a CI/CD motion for the CDE itself. And then you'll have a tiered self-service and self-fulfillment model at this point. And by that I mean you have at least 3 levels of self-service and self-fulfillment. Your less technical users, let's say you put some business analysts or something on here to run superset or something like that. They're not going to be able to write their own, or they probably don't even want to write their own templates. You know, they're going to either go to the platform team or maybe a lead dev on another team to get some help to say, hey, you know, here's this piece of software, we want to have it installed, we want to use it. So there is going to be a request and fulfillment cycle for that tier. The mid tier is a multiple choice infra and self-service dependencies. So this could be, you know, you could give the devs a choice of, say, you know, a CPU only node or a node with GPUs, and they could use like a dev container or dev container spec to spin up the workspace. So now they sort of have they have a couple of cookie cutters to pick for the hardware itself, but now they can define their own dependencies like in a dev container spec or whatever sort of declarative spec you're using. And then the third tier is the one I described earlier, where the devs are doing everything. They're declaring their own hardware, they're fulfilling their own dependencies, they're completely rolling. And if you think about like a DevOps loop, at the end of a planning phase, before you start coding on the next sprint, you know, the devs could go in and adjust their templates to have the newest version of the library or some other package that you need or whatever for this next sprint. So now, when everybody embarks on their coding tasks, everything's there and it's ready to go. So the bottom line on CD maturity and the golden path, incremental adoption and scoring, it matters, right? The smaller steps you can do, the easier they're going to be scored. And you want to keep scoring throughout the whole lifetime of the CDE, even after you've reached stage 4. And the golden path is key. It's a way, if you just look at the golden path and say, how can I make my devs happy by removing friction in their job? I mean, It pays off in multiples. And adoption and the golden path are journeys. Like I said, they're infinite games. You're always going to be incrementing, even after you've hit stage 4. There's always going to be some incremental improvements that you can make. So, trends. We got about 3 minutes here. I don't know if you guys are familiar with these Gartner hype cycles. This is the platform engineering one from last year. They haven't released the 2025 one yet, but CDEs are right there, right? So they're still kind of on the innovation trigger phase. They're getting into the peak of inflated expectations phase, and then it's going to be the reality is going to set in for people. So if you haven't adopted a CDE yet, you're not exactly behind the industry, but now's a good time to get ahead of your competitors, because CDEs are a strategic asset, right? It's the title of this talk. If you look at what a CDE can do, the stuff here on the left side, what can you do today with a CDE? We've talked about all these things, but once you get into those advanced stages, you can start looking at what can the CDE do for me tomorrow, right? That's where the strategic aspect of this comes in. These are just some things we picked out of thin air, green software engineering, AI augmented development, things like that. You know your industry, you know your products. This is for you to fill in, not for me to say what it is or what it isn't. So overall, the CDs enhance DevX and security, period. That's like the lowest hanging fruit out of this. If you implement a CDE, and even if you're not doing all the greatest tiering and everything like we talked about in the later stages, you are going to have a more secure developer environment, and your devs are going to be happier. The adoption is a journey, and it's a never-ending journey. You're constantly going to be iterating even after you've hit stage 4. And CDs are a strategic differentiator. If you can hire somebody from a top school, have them come in on their first day, and they're writing code and committing immediately, they're going to stick around, right? They're not going to get frustrated and walk out the door. So we're right at 45 minutes now. Oh, no, actually, we're a little bit under because I started my clock late. Anyway, resources. These are links. These are no good to you right now, but I'll have a QR code up for the slides, so you can grab the slides if you want. Coder.com, we have a really active blog. We publish a lot of white papers. We have a really top tier set of docs. And then we also have a fairly active YouTube channel. Hopefully it'll get more and more active as we go along. I did a CDE 101 video series on YouTube. So if you want to start talking about this stuff with maybe a business manager or your C-level folks, you can have them watch that, and it's like a nice little cartoon. It describes what CDEs are and how to select a CDE and things like that. And then we have some white papers that are really handy: introducing CDEs enterprise, state of the CDE report, the enterprise CDE buyer's guide, and then finally the maturity model, which is what this talk is based on. It's about, like a 25 or 30 page white paper that goes into a lot more detail than I had time to go into today. So if you want the slides and you want those links, that's the QR code on your left. And if you want to connect with me on LinkedIn, that's the QR code on the right. I will leave those up, and I will turn it over to you guys and ask you if you have any questions. Do we have a mic, actually? Because they are live streaming this. Yeah. There you go.
Hey, I like your presentation, and
Thank you.
I'm the Senior Director of Horizon Surgical Systems. We are making surgical robots.
Okay.
And because we are a medical devices manufacturer, I have questions for you on two sides.
Okay.
One is the compliance. Using the CDE in the process of the whole SDLC, do you see any problems, or do you see you have any successful clients that in the medical devices company industry that they're using the CDE and it's actually streamlined their workflow, but they don't get any problem with the FDA? That's number one. Number two is that we are dealing with the hardware. So do you see the CDE can help with not only for those companies, meaning on the cloud, but also for companies like us, dealing
Mhm.
with hardware, doing the deployment, doing the testing on hardware, like a hardware in a loop? That's my two questions. Thank you.
Yeah. So I don't know if we have any medical device companies right now. However, we do have a lot of companies who are in regulated industries, finance, and government and things like that. So a CDE will definitely help you with those compliance checks, because now you don't have to go out and to every single developer's machine and make sure that it's in compliance, right? Everybody's building off of this one declaration. You can spin that up and say, hey, is it compliant or is it not? What do we need to change to make it compliant? You change it in the declaration, and then the next time your developers spin up their workspace, they have all those changes, right? As far as connecting directly to the hardware, we have a way to do it right now that effectively you can attach. Remember I said you can do like a multi-platform or multi-cloud type CDE. We have a way now where you can actually have your laptop connect as a provisioner to your CDE. So if you want to hook a JTAG up or something, you can that way. It's clunky. However, that is, a lot of folks are asking for that, embedded use cases, and it is something that is, I don't know, is it on the roadmap right now or is it coming soon?
We're adding USB forwarding.
Okay, USB for web.
A remote instance and forward their local kind of USB
Yeah.
serial devices into that.
Yeah. So yeah, that's on the roadmap for this year, right? Yeah. So that, at least for us, I don't know about what the other folks are doing, but for us, that'll be a capability we have this year.
Thank you. So, small follow-up question on that topic is, how deep the CDE, for example, from Coder, can emulate on the cloud? Is it down to OS, like the kernel, or even down to, let's say, some settings in the BIOS even?
The workspaces can be just about anything. They can be, they can be a container, they can be a pod, they can be a deployment, they can be a complete namespace, they can be a VM if you want. So, it's all virtual, right? So if you could emulate those, like let's say you're going to use a VM, if your platform would allow the CDE to connect to the VM provider and change those kind of BIOS settings in the VM, then yeah, you absolutely could do it. But for hardware, I don't know what kind of hardware you're using, but if it's something where you're directly connected to a workstation and you can send those signals to the hardware to make those changes, then yeah, I don't see why not. The thing I always tell folks is, like for Coder anyway, we use Terraform. So on the platform side, if you can do it in Terraform, you can do it in Coder. But we're also OS agnostic on the workspace side. So if you can do it in your OS, you can do it in Coder, right? The OS that you're using.
Thank you.
Any other questions or? Anybody else? Okay, cool. Well, thanks everybody for coming. I'm really glad you guys stuck around, because I was really worried that there wasn't going to be anybody here, because it is like the last thing right before the keynote, and it's like across the way from all the critical mass. So I thank you all. And this was the first time I gave this talk, so hopefully I'll have a chance to give it a lot more. So if I stumbled over a few things or got a little confused, thanks for bearing with me on that. So thank you. Thanks.